Why is this? Okay. Hi, Lillian.
Hello. Hi, Karen.
How are you?
I'm good. How are you?
I'm good. Tired, but good.
Oh my gosh, tell me about it. I'm tired, and this morning I woke up to demo this one more time just to make sure everything's good. And the very last step, it doesn't want to work. So I'm super sad and my heart is broken, but you know what? We're going to just go along with it. We're going to keep it pushing.
Yeah.
Oh my gosh. But yeah, I'm hoping and praying the rest goes well. Like whenever there's a demo involved, it doesn't matter what I do, like something is bound to go wrong. Like yesterday with my workshop was fine because it was just like conceptual and it was just me talking. But now that I have to do something technical, now it's going to give me an issue.
Yeah.
Ugh, but oh well. But yeah, thank you for moderating. I appreciate it.
No problem. I'm happy to help in any way, really.
Thanks. Yeah, so I'll have you moderate, and I just had like one of my committee members, like I guess he'll just be in the chat to like paste like commands if they need them. That's about it. That's all I have prepared is the slides and then a demo, and then we'll be on our way. Actually, let me make sure this comes
All
up.
right.
Okay, good morning, everyone. Alrighty, so we're gonna go ahead and get started. I see your question, Noah, where you said that you downloaded the Docker engine, but it says it failed to start. Are you on, yeah, I think Justice is gonna try to help, but are you on a Windows machine or a Mac machine or Windows? Okay, so I am running Docker here on Mac, and I'm not sure if this is an issue anyone else is going to run into when it comes to Windows. I know personally when someone had to download Docker on Windows, they had to like restart their computer. So I'm not sure if that will help your troubleshooting issue where it says failed to start. Oh, you did. I'm honestly, what else have we here? Okay, yeah, Justice says he had to change a setting in BIOS and then it was able to work for him. So apologies if that happens to you, but we're gonna run through the demo and this is recorded so you'll be able to see it. So if you don't have the opportunity to do it along with me, then the recording is always here. So we'll go ahead and get started then. Okay. So once again, good morning, everyone. I hope you got some rest between all your hacking and staying up super late. Thank you for joining us for our Containerization with Docker workshop. So today we're going to discuss what Docker is, its advantages, some common commands that you can use with it, and of course, we're going to follow it up with a demo. So if you'd like to follow along with the demo, I suggest you download Docker now. I hope it doesn't give you any issues like it is right now for Noah. But if you go to your hacker guide and you click the drop-down button, there should be a link to go ahead and download Docker. What if I have on one Mac? Honestly, I'm not sure. I would hope that it would run the same as a standard Mac, so not sure. But yeah, so like I said, if you don't have the opportunity to download it, if it's taking too long or something like that, or you have to restart, don't worry. The demo is going to be at the end, so if it's installed by then, great. But if not, just come back and look at this recording. So, all right, we'll go ahead and get started. So what is Docker? We have to start with that, of course. So Docker is a tool that allows developers, sysadmins, etc., to easily deploy their applications in a sandbox or containers in order to run on a host operating system like Linux, for example. So when it comes to Docker, all of the dependencies are standardized into one unit, and containers can the containers provide most of the isolation of virtual machines at a fraction of the computing power. So Docker is a super popular containerization tool. Another tool that's similar that you might have heard of is like Kubernetes, but we're doing Docker today. And it's a DevOps tool. So you may have run into this issue before where you have to, send an app or a program to your friend or your boss, etc. And once it reaches that person, once it reaches their machine, it doesn't want to run for them for some reason or another. Maybe they don't have the same packages and libraries installed, so on and so forth. So the goal of Docker is to kind of help minimize that. So Docker packs up your code, your variables, configuration files, dependencies, all of that and more into one container, so all of that can be avoided. So Docker does this by essentially isolating the application. So here's a diagram of kind of how this works and how the containerization works and the structure of it. So traditionally with a virtual machine, each individual application runs on top of a VM and like on top of a host operating system. And so the goal, so here on the right is how it's like essentially usually kind of structured. It's running on top of a hypervisor. And hypervisor is just a software that allows a VM to operate directly on the hardware, and it enables you to run multiple virtual machines, as you see here. But this is super clunky. It's not super efficient. Whereas with containerization, all of these apps are able to run on top of Docker, on top of the one host operating system instead of guest operating systems on top of one infrastructure. So this is a little more containerized, as you can see. I see a question. Would you be able to go back to the previous slide? Sure, I can go back super quick. I don't know if you want to, I don't know if you're like taking notes or anything like that. This is the previous slide for you, Noah. Okay, perfect. All right, so we're gonna keep moving on. So yes, this is basically the structure of a VM here to the right versus a containerized application. So let's talk about virtual machine disadvantages, right? So a virtual machine simulates all the hardware of a computer, which takes up a lot of computer resources. The boot time takes a while, and then multitasking is super challenging because each of these has to run within their own kind of little virtual machine, and it's not very efficient. The Docker advantages kind of like greatly outnumber the disadvantages for VMs. So there's much less overhead than a VM, as it accesses resources from the host directly rather than virtual access through a hypervisor running on a whole operating system. It's significantly faster because the computer does not have to create virtual hardware. And then there's fewer layers that are required to manage compared to that VM. So if you saw in that structure, there's a lot less layers as opposed to a virtual machine. And then lastly, with Docker advantages, we can notice, yeah, like I said, we notice that there's fewer layers. And then all the code is isolated into a lightweight container, and it can easily be moved and ran anywhere, giving it instant portability. So it's also great for testing software in different environments. So like we talked about earlier, it's super easy to transport to someone else for them to gain access to it, etc. So that's all of the advantages of Docker as opposed to running your application within a virtual machine. So now we're going to get into some basic terminology that you'll hear when it comes to Docker. So we start with an image. So an image is essentially the blueprint of our application, and that is what forms the basis of a container. And an image is kind of made up of multiple layers, like you can see here with this diagram to the right. So there's, like I said, they're essentially the blueprints, and they're made up of layers. And images can be moved around, and they live on the Docker Hub. So on the Docker Hub, you can upload custom images to your Docker Hub underneath your username. It's similar to GitHub, and I'll actually show you guys an example of that a little later. Okay, so now we have containers. You probably heard me mention this a few times now. So a container is an environment with all the necessary installations done for the application that's running in said container. So each container has a running app, and each container itself runs on top of the Docker engine. So think of it like a logical packing system. So we see this is kind of the logo for Docker to the right. It's like a little whale and kind of like a shipping barge in a way. So that's exactly what you can imagine. So imagine a super large barge with its respective shipping containers, and they're all packed up neatly to be shipped out and deployed to whoever you need it to go to. And then lastly, when it comes to terminology, we have a Docker file. So it's a simple text file that contains a list of commands that the Docker client calls while creating an image. It's a simple way to automate the image creation process. And the commands you use in a Docker file are really similar to Linux commands. So in summation, it's essentially a checklist or like a blueprint of how to build an image. And so I'm going to show you all some common commands. And if you're familiar with Linux, you'll exactly see how these are kind of correlate similar to Linux commands. So with the command PS, that kind of lists all the containers that you have like currently. With the run command, that's how you actually start a container or an image. With the ps.-a command, this outputs all the running and stopped containers. Obviously with stop, this is a command that's going to stop the containers. Obviously you have to put the name at the end of stop for all of these commands. You have to include the name so it knows exactly what it's doing. Then we have the rm command, which removes a container. The images command lists images that you have. RMI specifically removes images. The pull command downloads an image without running the container. The exec command executes a command, and then run attaches and detaches, and then run with 2 dashes ends up naming the image or the container that you so choose to put at the end. Alrighty, so like I said, Docker actually has its own repository, and it's super similar to GitHub. So here you can find various libraries and dependencies in order to help like build out your image/container. And then additionally, this is where you're going to push and pull containers to share with other people. So if you happen to have Docker successfully downloaded, I don't remember if it prompts you to make an account right when you download it, but if not, that's something that you can go do if you'd like, because a little bit in the demo we'll have to use Docker Hub. And I believe I'm going to type the link here. It should be Docker Hub, hub.docker.com. Hopefully that works. If it doesn't, I will get you a different link. But yes, so that is a little bit about Docker Hub, and we'll see that a little later as well. So like I said, we're going to go through a demo. Okay, it works? Okay, thank you, Justice. So we're going to go through a demo, and this is essentially the path that we're going to take. So I want to show you exactly what we're going to do in order for you to like understand the steps of how an image is created. So first, we're going to start with creating a super basic Flask application, super basic Python web app. And it's just going to read off one line of code just so we have something to turn into an image, right? And so in order to generate a Docker image for this application, we have to basically tell the Docker image, hey, we want to install Python because we're going to be using Python. So this is the language you have to have installed. Install pip3, which is basically just like a package manager that has all the dependencies that we need for Python 3. And then we're going to copy the source code from our Flask application so that it knows what's in our application. It knows what we're running in our app. Then we're going to expose the port that it's going to run on. We execute it, and boom, we have a new Docker image. So that's the kind of flow that this follows. It looks kind of like odd when you look at it this way, but we're going to walk through it, and hopefully it makes a little more sense in a minute. All right, so now we're going to get to setting up our computers. So once again, if you successfully installed Docker, I am going to invite you to go to your command prompt or your terminal. And this is where we're going to spend most of our time for the rest of the demo. So let me go ahead and switch my screens and give you all a moment to open that up. So give me about 2 seconds. Okay, great. So I have my terminal mode up. Your command prompt, if you're in Windows, whatever you kind of use for this. And everyone can see this okay, right? Let me know if I should zoom in a bit. I know it's a little small. Is that a little better? Okay, great. Alrighty, so this is the first command that we're gonna run once we've successfully installed Docker. So it's docker run hello-world. It's gonna take a minute. Okay, so this is the message that outputs, and this is great. This message shows that your installation appears to be working correctly. So we're on the right track if you've received this message. So it tells you a little bit more about Docker, Docker Hub, how to get started, all of those things. My system reported the daemon isn't running. How do I start that? Start the daemon. Let's see. When you installed Docker, did you have the option to kind of move the actual icon into an application folder? Zoe? Yeah, because if not, I feel like I'm on Linux and I ran sudo pacman -s docker. Okay, and so when you ran this command, it gave you that daemon error, or daemon, however you pronounce it. And sudo pacman. Okay, well, I'm honestly not 100% sure. The command gave me a daemon error. Okay. Yeah, I'm not sure, mostly because the command line that you just provided, sudo pacman flag s docker, I'm not really sure if that was, is that basically the kind of prompt it gave you when you installed it? Okay, it's like, okay, it's like apt-get. Okay, so it's like a package installer. Okay. Well, this is the thing that I was going to say. If you downloaded the Docker application, sometimes you're able to go, there's like a dashboard, and you're able to kind of troubleshoot from there if you see a Docker application. But if I'm being 100% honest, I'm really not sure why that error came up and how to resolve that. But for the time being, I'm going to keep going. So you can just watch along, and hopefully there's like a solution for that error that we can come across a little later. Maybe we can troubleshoot a little later. But okay, so if you've gotten this message, that means great. It's appearing to work. Okay, thank you, Zoe. I appreciate it. Great. So yeah, so that means we got it up and running. So additionally, to make sure that we're all set and we're all good, we can run this specific image. So I'll have you all type this. So docker run docker /whalesay. And then we're going to type in cowsay. And we're going to say, welcome to ShellHack. So let's see. Okay, great. We get this cute little whale here, and it tells us welcome to ShellHack because that's the kind of text that we ended up piping to it. So this is actually an instance of our very first image. So right here where it says docker /whalesay, this is a image that already exists on the Docker repository, and all we had to do is run it and it pops up. So that's as simple as it is to like pull things from the repository. So that's just an example to make sure that we're all up and running and ready to go. So great. Now that we have that, let's, oh, and actually if we type in Docker images like this will list all the images we have running. So obviously you're not gonna have all of these because these are all of my demos and tutorials, etc. But if you look down here where it says latest, this is Docker whalesay. This was created by Docker like 6 years ago. So that's why it's all the way down here at the bottom. But yes, so there we have our first image. So when you type in Docker images, you should be able to see that within your list. And thank you, Alan, for sending the troubleshoot. I appreciate that. Alrighty, so now that we have our Docker set up, let's go ahead and create our basic Flask application. So when it comes to this application, you all can use whatever text editor you'd prefer. If you'd like to use Vim within your terminal, you can do that. Today, I'm going to be utilizing Atom, but like I said, PyCharm, VS Code, literally anything that you'd like to use, you can for this Flask app. It's going to be super simple. All it has to do is be able to run Python. So, okay. Oh, prior to that, just in case you all don't have Python installed, there's a few package installers that you can use to do this. So just like Zoe was doing with Linux and her package installer, one that's super common is apt-get. So in order to make sure you have Python, you can do apt-get install Python 3-pip. I'm not mistaken, just kidding. Okay, this is what happens. So sometimes you'll get this crazy command like ABT get not found. If you're on a Mac, something like that. I think a workaround for that would be sudo easy _ install. And then you'll have to put in your password. And there we go. It makes sure that you have all your dependencies installed for pip. And then additionally, to make sure that you have any dependencies that you need for our Flask application, you'll do pip install Flask. And I already have it installed. I think there's going to be like an update or something soon like that. But yes, so pip install Flask, that means that we're all set to create our Flask application, right? Okay, so in order to create the Flask application, first we have to go ahead and make a directory for it. So this is within your terminal still. If you kind of just opened it up, you should still be like at the kind of root basically of your like user for your terminal. So we have to go ahead and navigate to our desktop desktop folder. So we do cd change directory desktop, and boom, we'll know we're in our desktop because it appears right before the % sign. Now let's go ahead and make a folder for our application. So we use the command mkdir, so make dir, make directory, and let's go ahead and call it ShellHack's app or something like that, something simple. So great. That's our directory. We have to navigate into it. So change directory, ShellHack's app. And we're inside it. So great. So now that we're inside it, we can actually go ahead and start making our Flask application. So let me go ahead and pull up Atom, which is what I'll be using today. I like to use this just because I feel like the interface looks a little better than doing it directly within the terminal, honestly. And I like to just kind of pull up my folder from here. And let me make sure I'm checking on the chat if anyone has any questions. Okay, great. So here we're going to add our folder. And I'm just going to go straight to desktop where I had it, and we called it ShellHack's app. So boom, right here. We go ahead and open it up, and now we're going to create our Python file. So we do this by adding a file right here. So I'm going to go ahead and just right click so you can see everything that I'm doing and click new file. And we're going to call it ShellHack's app.py. Awesome. So this is where our Flask application is going to live. So I'll walk you all through the steps for each of the lines of code for this Flask app. But like I said, it's going to be super duper simple. It's not going to be anything super fancy. Obviously, if you have a bigger application, you'd put all their dependencies, etc., within this. But it's super simple, so I'll just show you. So first, we have to import Flask. So we'll do from Flask import capital Flask. Okay. Then we have to create an, let me make sure this is capitalized. Okay, now we have to create an instance for our web application. So we do this by saying app equals Flask, and then in parentheses, we'll do double underscore name double underscore. Okay. So now that we have our instance run, we have to, instance created, we have to go ahead and make an if statement in order for our application to run. So we'll do if underscore underscore name, sorry, I can't type this one, underscore underscore equals name. And then end that with a colon. We'll do app.run parentheses colon. Alrighty, so that's the if statement that we're going to use to make sure that our application is going to run, right? So next, in order to define the pages that we're going to have on our web app, for simplicity reasons, we're just going to have a home page. We're going to define that right above our if statement here. So we'll do define home in parentheses with a colon at the end again, and tab down, return, we're gonna do hello ShellHacks instead of hello world, right? So there we go. That's the text that our app is going to return. And then a few more steps. We have to define how to access this page. We have to give it a route. We have to give it somewhere to go. So when we do that, we'll do app or the @ symbol, app.route, and then parentheses, quotes, and backslash. Okay, so let me know if I need to slow down, if we're all together. Okay, if so, then that's great. We'll keep on going. And then we have one last thing to make sure that our application is going to run. So we do this by doing app, oh, just kidding, not app.run. Within our parentheses of app.run, we do debug equals true, and then comma host, and we're gonna set the host to o.o.o.o, so 4 zeros. And if I'm not mistaken, I don't think I need a colon at the end. So, okay, so this is essentially going to be the bare bones of our Flask app. So I'm going through, making sure I didn't put any typos or anything, because that is definitely a pain. Return hello ShellHacks if mean. Okay, great. So I'm gonna save it this way once again, so you all can see everything that I'm doing. So I'll save it here. And in order to run it, we're gonna return to our terminal mode and type in Python the name of our application, which is ShellHacks app.py, and then put that in quotes and go ahead and click enter, and it runs it for us. So great. You can ignore this about being in a development server and a production deployment. Honestly, best practice is to do this within a virtual environment, but just for demo purposes, we're not going to do it that way. But you should get an address here with the location of 5,000 here at the end. So go ahead and copy this and pull it into a browser of your choice. Doesn't really matter. Okay, and then when I pull in this browser and I click Command V and paste it, we get our web app, Hello ShellHack. Super fancy, super, robust, I know. But yes, so this is just for demonstration purposes, of course. So this is our Hello ShellHacks app. So great. Now that we have an app, we can turn it into an image. So now we get to the actual nitty gritty of the demo. So we'll go ahead and click Control C like it says to end that. And we're gonna go ahead and go back to our text editor to create our requirements TXT file and our Docker file. So let me make sure once again that I'm not missing anything. Okay, great. So we'll do the same process. Go ahead and add a file here, so new file. And this is gonna be our requirements.txt file. So requirements.txt, great. So here within this file, essentially, this is when we're telling Docker what version of Flask that we're gonna need. So we do this by typing simply Flask equals equals double equal sign 0.10.1. So that's the version of Flask that it needs to run, basically. And that's all that's required for this demo. Once again, if you have more dependencies and more things that it needs, this is where it's gonna go as well. But we'll go ahead and save that. Now, the other component of this is going to be our Docker file. So once again, new file, and simply type in Docker file. So I'm going to go through step by step with this, because this is what I was talking about when it comes down to almost making a blueprint for your Docker container in a way. So we do this by starting with from Ubuntu, and then a colon and version 16.04. So you can kind of interchange this for whatever your application needs. So if it's not running within Ubuntu, maybe it's CentOS or Red Hat or Debian or any of those things, that's what you're gonna put for that. But we're gonna run it on Linux, essentially Ubuntu, and this version. So from Ubuntu 16.04. Great. So next, we're gonna put this line of code here. So bear with me. So run apt-get, which like I said earlier, is the package installer, update flag y. And then this double ampersand is just so that we can continue the same command onto the next line without having to like have a super long line. And we'll indent it a bit here. apt-get install flag y python-pip python-dev. Alrighty, so basically, if you remember when we were in terminal mode and we were doing our pip install Flask, all of that, essentially you're telling the Docker file to do the same exact thing. So we have our pip and we have our Python pip, and it has its package installer, so it's going to do it for us right there. So that's what that command line is for. Next, we move on to, we'll not indent anymore, we move on to copy // requirements.txt space app / requirements.txt. So essentially with this line here, we're literally copying all of the text that was in this file right here and making sure that that's present in our Docker file. So this is just to copy it. Now we have to copy it to a directory, right? So we're going to use this command workdir or working directory /app. So essentially we're copying all of this to this right here, right? And then we have a couple more lines, almost done. We'll do run pip install flag r requirements.txt. So with that one, essentially, once again, we've copied it all and now it needs to run. So this is giving it the command to go ahead and run that txt file. Not one more, but like a couple more. So copy space period space /app. That's going to basically, once again, copy all that we have here up into this directory. So here's us making the directory. Now we're copying it over to this directory. And then we're coming down to our final couple commands. So lastly, we do entry point and brackets and the words Python in quotes. And then lastly, cmd and brackets. And in quotes, we're going to call this app.py. Alrighty, so this is essentially our blueprint in order to get our Docker file to generate. So like I said, this is literally a step-by-step guide, a step-by-step checklist that of all the things that need to get done in order to copy everything from this to our new file, basically. So file save, and let me once again check the chat. Okay, good. I'm sorry. I don't see the chat right now, so I have to go back periodically and double check, but it seems like we're all good. Glad we're following along. Now we're going to return to our command prompt and essentially build our image, right? So here we come back to our command prompt. Make sure that you're still within your same directory for your app. And we're going to type in this command. So docker build flag t, and now we're going to give this image a name. So let's call it shell-flask. And this is the tag latest. So essentially what this does is just gives it a tag to kind of organize it. This is a super important part. It's a space and a period. Without that period, it's going to not work. So this is the command that we run. So all it's doing is, like I was saying, going through the step-by-step that we gave it. So step one, it's taking it from Ubuntu. It's realizing that we're running this off of Ubuntu. It's running any of the package installers that it needs to. Now it's getting all of the packages and the dependencies we need. Now it's a little crazy. Give it a second. Okay, is it there? Still going. Still going. Okay. Okay, great. I see the word done, so let's hope that it's done. Okay. Okay, it's getting down to the bottom. Here we go. Okay, so now we've gotten to step 3, step 4, 5. It's gonna do a few requests. Wow, this is taking a longer time than normal. Okay, great. We've made it to the end. Awesome. So that was basically spinning up the image that we're going to use. That wasn't even to run it just yet. It kind of just created it essentially, right? So now that it was successfully built, our image, we're going to go ahead and run it. So we'll do Docker run -d -p to expose the port that we're going to have it on. And it's going to be 5000:5000. And then once again, we're going to use the same name of the image, so shell-flask, and tag it with latest. Oops. And great. There really is no processing for that. It's just one line and we're good. So awesome. We now have an image and everything is copied over and we ran it. And if we want to make sure we did that successfully, we run this command, docker ps flag a. And this gives us a running list of all the images that we currently have running. So if we come all the way here at the top, it's perfect. We have our shell flask latest. So awesome. We did that just fine. That's exactly what we needed. So great. So like I said, oh, actually, this is another command that you can practice with too. This is one that we saw on the slide. It's called remove image. So we'll do docker rmi. And in this case, maybe we want to remove this whale say image that we just made earlier. We don't really need it anymore. So we'll just copy and paste the container ID. Come down here, paste it at the end. And then, oh, it says no such image. Why did it say that? Can I not copy it? Docker RMI. Let's just do RM and see if that works. Okay, perfect. Sorry, my bad. RMI is for an image, RM is for a container. So we have our container here. So we ended up removing our Docker whale say container. And to make sure it did that successfully, we'll do another Docker ps flag a. And we come up here to the top, and it's no longer there. This is where it should be. It should have been right after our shell flask container, but it's gone. So that's how we remove a container. So awesome. We have our container and our image all spun up for our web app. So now we're going to do our best to push this to Docker. So if you're able to make a Docker account, great. This is when we're going to use it. You're going to use this command, docker login. So for myself, it's going to go ahead and authenticate it automatically. If that doesn't happen for you, it's probably going to prompt you to enter in like a username or a password that you use for your account. So go ahead and do that now. And that'll log you into Docker essentially. So in order to push this to our repository, we have to kind of tag it first. So we basically have to put it within our repository. So we're going to do Docker tag and the name of our image. So we want to use this one, which is shell flask :latest, and paste it here. And then lastly, we're going to use our username for Docker Hub. So my username for Docker Hub happens to be this. It's Lillian, but just with an X. And then I'm going to do a backslash and then paste our image name one more time. So that's essentially kind of directing our container with a place to go. So we'll enter that. Nothing crazy happens, and the next couple steps we'll see if it's successfully pushed. So we're gonna do Docker images again. And perfect, it did it just fine. You have my username and then the name of the image and then our tag here. So great, that means it was successful and we can go ahead and push it all the way. So we'll do Docker push. Once again, my username and the name of the repository. I don't believe I have to have the tag on it for that, with this portion. So we're gonna go ahead and push it. And it does it for us. So we're gonna give it a second. Still going. Almost there. This actually does run faster, but of course, when we are doing a technical demo, things have to go a little slow. That's always how it works. So almost there. Okay, great. So let's double check and see if we successfully pushed it. So we can go ahead and visit the actual Docker Hub site. So we'll do hub.docker.com. And if you're successfully logged in, it should be your username up here at the top. So like I was saying, it's super similar to GitHub. So over here in your repositories, I'm already here. We'll see ShellHack was successfully pushed here and it's now public. So like we were saying, it makes it super simple to send it to whoever you need to. They have it right here. So yeah, here's some other like repositories that I did for demos, etc. So yeah, so here's our ShellHack app. So great, if we wanted to push it again, this is where we would copy and paste it. But we pushed it. Now we want to try to pull it so we can see what somebody else would have to use, basically. So when you go to the public view, this is what they will have access to and what they can see. So they'll see this command right here, and it's super convenient, Docker pull, and you just copy that over. So it's automatically copied to our clipboard. We return here to our terminal mode, and we go ahead and paste that. So Docker pull, our username, and then the name of the image. Great. So we'll do that. And to double check and make sure that it's there, we'll use this command one more time, Docker images. So yep, we know that it's there because boom, there's our username and the end of ShellHack there at the bottom. Okay. So because they pulled it and they don't necessarily need this one with the repository with the one with the username anymore, we can go ahead and get rid of that. So Docker RMI, copy this one more time, remove it, successfully removed, let's see. Yep, successfully removed, it's no longer there. Great. So now we come to the part where we actually want to run our application. So in full transparency, like I said, whenever we have technical demos, something is always bound to happen and go wrong. So as I was testing this today to make sure it was all good, I haven't been able to actually get it up and running, unfortunately. But I'll show you how to do it and basically the command that you'll have to use in general. So we'll do docker run -p. So we're going to expose the port that we want it to reside on. So if you remember specifically when we were building this, we did 5000 colon 5000, and we'll go ahead and list the name of the image that we'd like to pull up. Yes, so go ahead and run it. And yes, this is the issue that I was running into today. It's an error, no such file directory. So I believe this has to do something with like the file directory and how it's basically kind of set up in the hierarchy of it. And I've been trying to get to the bottom of it. So that's my task today, is like troubleshooting this. I'm going to try one more thing and see if that works. If not, workaround basically. So docker run -p 5000 colon 5000. And then let's see if we do shell Flask without using, if that'll help. Nope, still didn't help. Alrighty. Well, like I said, we're going to do our best to work around that. But anyways, so that was how you could do all of this basically within terminal mode. Docker is really great because they have set up a dashboard where you don't even have to really even go through all of those steps in order to do that. You essentially just have to go to the dashboard that they've already drafted up. So like I was saying, if you actually successfully downloaded the application, you should have access to it. But right here, up here, I have access to it right here. So if you click this, our little whale, and you click dashboard, it should pop up in a second. Okay, great, here it is. Let me move it over to the screen. So it's telling us there's no containers running, and that's fine. But essentially all of the work we kind of did with checking on images, removing images, so on and so forth, can be done directly here from their dashboard that you have installed. So we see our shell Flask here, the one with my username and all those previous demos, and we can see that they're all in use. Their tags, their IDs, when they were created, the size of them, everything. So instead of like using commands like run or so on and so forth within the terminal, you can literally click run right here and do that in that way as well. You can, I'm going to cancel that because it's already in use. And then if you click these three little buttons here, you can inspect it, pull it, and push it to the hub, all from this dashboard as well. So this is kind of the super simple, easy workaround to kind of work with your containers, especially if you have multiple ones going on. I think if I go ahead and click inspect, you can kind of also see some of the bash and like the shell code behind it. And usually when I click it and I try to run it, it gives me the similar arrow that we saw within our command line. I'm trying to look for it now. Let's see. Shell Flask, it also generates like its own kind of names here at the top over here. But let's see if I click start, if it'll show me. Yeah, no, okay. It's not showing me, but yep, so we already know that this container is running, it's already in use, but sometimes it'll pop up here with a similar error command that we got within our terminal, letting you know, hey, there's something going on, we can't open your app, something about the file or the directory is the error that we're getting today. But essentially, if this were to go fine and swimmingly and smooth, the person who is pulling this would have access to this exact app here within this port where you kind of housed it. And it would say, hello, ShellHacks, or whatever nice, intricate kind of web app that you were able to kind of draft up at the time. So this is the kind of basics of how to create a Docker image and container, push it and pull it to your repository, and how to use it from there. So that kind of brings us to the end of our demo. And if you weren't able to follow along, I apologize. I hope you come back and look at this for some tips and tricks, etc. I know as we kind of have different operating systems and stuff, things get a little weird. But luckily, like I said, terminal mode, the commands don't really differ too much except for like package installers. And push comes to shove, you always have your dashboard here with Docker to use that too. So far, With anything that we discussed, are there any questions that you have, any commands that you need me to repeat or, share or paste into the chat, anything like that? And if not, no worries, all good. Like I said, this recording will be posted, or you can ping me within Discord if you'd like to, get access to this. Do I have a Twitter account? I do not have a Twitter account or a blog for any of my guides or tutorials. But UPE does have a YouTube account, so that's where all of these will be. And there's a plethora of other tutorials that are already on there. So I would definitely ask you to check that out. I don't have the link right now. Maybe if Karen or Justice can look for the link, maybe they can drop it there. But no, I do not have a personal blog or Twitter for the tutorials. Okay, yes, thank you so much, Justice. I appreciate it. But yeah, so like I said, this kind of brings us to the end of our demo. I hope you guys were able to learn something new. Yeah, Docker is super helpful when you have really intricate applications that you need to go over and send over. So yeah, this is definitely a DevOps tool that is heavily utilized within the industry. So yeah, so thank you all for coming. I really appreciate it. Happy hacking. I hope your projects are going well. And like I said, any questions, just feel free to ping me on Discord and I'd be happy to help in any way that I can. Thank you, guys. Thank you. Alrighty, so if there's no further questions, I'm gonna go ahead and close the room because that's what ends the recording. So once again, thank you guys for coming. Thank you all for making it out, and I hope you have a great rest of your hackathon. All right, have a great afternoon.